Welcome back, children. Today we will study about the effect of temperature on change of state. Now you know that a solid when heated gets changed into liquid. When the liquid gets heated, it gets changed into gas. So change of state occurs due to absorption of heat in this case. So when a solid absorbs heat, it changes to the liquid state. When a liquid absorbs heat, it changes into the gaseous state. On the other hand, when a gas liberates heat, gives out heat, it changes to the liquid state. And the liquid, when liberates heat, when gives away heat, it changes back to solid. That means temperature plays a very big role in change of state of matter. Now think of ice. When you put ice in a beaker, put a thermometer, lab thermometer at room temperature, and we will find that initially maybe the temperature of ice is minus 10 degrees centigrade. Then gradually as ice starts absorbing heat from the environment, from minus 9, the temperature increases to minus 8, minus 7 degrees centigrade, minus 6, minus 4. In this way, it comes to 0 degrees centigrade. Now we will notice that after the temperature reaches 0 degrees centigrade, the temperature does not rise further. That means the thermometer now stops showing increase in temperature. Now here you will see that at 0 degrees centigrade the temperature has become constant, and now you will find that the ice is melting. The temperature will continue to remain at 0 degrees centigrade until and unless all of the ice inside the beaker gets changed into water. Now big question here is, all this time, why was the temperature not increasing in the thermometer? Was ice not absorbing the heat at that time? If the ice is absorbing heat, definitely it is absorbing heat, then why is the thermometer unable to measure that increase in temperature? Now here is the answer. Listen carefully. During all this time, though the ice was continuing to absorb heat, it was not recorded by the thermometer. Why? Because that absorption of heat was utilized in breaking the intermolecular force of attraction between the particles of ice. Hence, it was not recorded by the thermometer. That means this heat was hidden or concealed, and for that reason the thermometer could not measure by showing increase in temperature. So this hidden heat or concealed heat is called as latent heat. So you can define, now there is latent heat of fusion or melting. When solid changes to liquid state, then we apply latent heat of fusion or latent heat of melting. Now melting is also called as fusion. Similarly, same thing will happen in case of water. When you put water in a beaker, say at room temperature 25 degrees centigrade, and put a thermometer in the beaker and now start heating, you will find that the temperature shown by thermometer gradually rises. It rises from 25 degrees centigrade up to 100 degrees centigrade. And at 100 degrees centigrade, when this temperature has reached to 100 degrees centigrade, there is no more further increase in temperature recorded by the thermometer. But you are heating from below. That means water is definitely absorbing heat. Now you will find that the water is boiling and now it is turning into steam. That is the gaseous state of water. Now why is the thermometer not capable of recording this absorption of heat by increasing the temperature further beyond 100 degrees centigrade? That is because that heat is being utilized for breaking the intermolecular force of attraction between the particles of water so that it gets changed into the gaseous state, that is steam. So again here there is the latent heat of vaporization which comes into play. So two types of latent heat you will read. One is latent heat of fusion and one is latent heat of vaporization. So latent heat of fusion may be defined as the amount of heat absorbed by 1 kg of ice at atmospheric pressure to convert it into water. So similarly, you can also define latent heat of vaporization. So children, latent heat of fusion may be defined as the amount of heat energy required by 1 kg of a solid to get converted into liquid at its melting point at atmospheric pressure. In a similar way, you can also define latent heat of vaporization. Now let us come back to the change of state from solid to liquid. Now when you heat a solid, what happens? The kinetic energy of the particles increases. As the kinetic energy of the particles increase, they start vibrating. As more and more heat is supplied, these particles start moving with a greater energy. They start colliding with each other and they leave their fixed position and move about with great speed. As more and more heat is absorbed by the solid, they leave their fixed position and move away from each other, breaking the intermolecular force of attraction to such an extent that the intermolecular space increases and hence it starts changing into the liquid state. This is how it happens. Same thing happens in case of change of state from liquid to gas. I gave you the example of change of water into its gaseous state, that is steam. What happens? As the temperature rises, now water already, the particles are in motion. The particles of water are already in motion because it is in the liquid state. They are having some energy, they are having some kinetic energy. Now when you apply heat, these particles absorb more and more heat and start moving with great speed in various directions, colliding with each other, and they move further and further away from each other. A time comes when this force of attraction between the particles becomes almost nil or negligible. At that time, the particles start leaving the surface of the liquid and then moves into the air. That means the change of state starts to occur and hence a liquid changes to its gaseous state. So this is how all these things happen. So change in temperature is very important in case of change of state. Clear? So in our next class, I will give you one short diagrammatic representation of change of states of matter by effect of temperature. Thank you. Please like the video and share it with all your friends. Thank you.